Are you looking to start a career in data analytics and master the Microsoft Power BI Data Analytics tool? Welcome to Excel Island, where we are learning the Microsoft Power BI tool over the next 100 days. Today is day 21. So if you are new to the channel, you can catch previous live stream on the channel where you covered some aspect of Microsoft Power BI over the last 20 days. You don't want to miss that. Also, all data set, exercise files, Power BI files are already linked under the YouTube description. Do make sure to download them and practice along with me. Without further ado, let's get back to learning and welcome back to day 21. I'm super excited. We have a lot to catch up with over the next 100 days. Let's continue. So basically, we're actually using the DataCamp platform to learn and master the Microsoft Power BI tool, and I'm enrolled on the Data Analytics in Power BI career track. So over the last 20 days, we've been doing quite a lot of learning. You can catch all those on the channel. We've also covered associate data analysis in SQL when I started live streaming on this channel. So after the Microsoft Power BI, which is the data analyst in Power BI career track, we are definitely starting the data analyst in Python career track also. So do make sure to subscribe right now, put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. Support the channel, just subscribe, hit that red button, put on the bell so you get notified when I come on live stream or drop a new content on the channel. So let's continue to data analyst in Power BI. So I click on that. I just want to show you all what we've covered so far. If you are new to the channel, what you've missed. So we've covered introduction to Power BI, introduction to DAX in Power BI, data visualization in Power BI, and we did a case study after studying these three concepts in Power BI, which is analyzing our customer churn in Power BI. It was an interesting case study, and I'm working on a video entirely just for it to show you this case study, how I went about it, and analyzing this case study and designing my reports and dashboards. So watch out for that video. We're actually on data preparation in Power BI over the last few days, and amazingly, we are going to finish this data preparation in Power BI today on this live stream. We're actually on the last course, which is numerical transformation in Power Query. So we want to learn how to transform and clean numerical data type in Power Query, which is data preparation in Power BI, just before you start analyzing your data set to make sure your data is clean. You're going to use the Power Query tool in Power BI, also in Excel. So they pretty work the same way. You get it now? So we still have a lot to cover. You can see data transformation, data modeling, intermediate data modeling, and quite a lot to cover. So we just continue from where we stopped on day 20, which is data preparation in Power BI. If I click on this course and continue, so it's going to take me here. So we've covered all of this. Let's continue to course. So if I click on course outline, you can see we've covered chapter 1. Most of the time, each course in the career track actually usually contain four chapters. So you get it now. Some 3, minimum of 3, maximum was 4. I've never seen a course containing 5 chapters before. So we've covered the first 3 chapters in this data preparation in Power BI. You can catch those lessons on previous live stream. So let's continue from this numerical transformation in Power Query. So let's finish what we've been learning so far about Power Query. So I just put on my headset real quick, and I have my files opened, everything set up, and ensure to download the files under the YouTube description so you can practice along with me.
Transforming numerical data is a crucial skill to learn for data analysis. We will learn how to use Power Query's features to fix errors as well as improve our numerical columns to produce high quality analysis. Earlier in 2016, a Harvard Business Review article cited an estimate from IBM that bad data costs the US around $3.1 trillion a year. That is a staggeringly large number, representing around 1/6 of the United States GDP at the time. The article went to explain that stale and unverified data was being used to make huge economic decisions, which ended up backfiring and caused companies to take dramatic measures to recover those losses. A good rule of thumb to follow is the 1-10-100 rule. It costs a data analyst $1 to verify that a single row of data is valid. It costs $10 for that data analyst to clean that row if any missing or incorrect data is found. Finally, it costs $100 if you leave the data as is and do nothing. Imagine how many rows of data a single company has, and you can imagine how that 3.1 trillion figure is not so unrealistic. Most of your analysis will depend on the contents of your numerical data columns, and basing your results on unclean numbers could lead to a catastrophe. Ideally, you want your numerical columns to be completely free from missing values and errors so that measures we build using DAX will function correctly. Outliers will also affect your analysis, but they will require more advanced tools, which we will learn later. You can use a variety of mathematical transformations on your numerical columns if you had a good reason to apply them. The most useful of these transformations will likely be the absolute value transformation, which gets rid of all negative values in a column. Applying logarithmic transformations to a column is a way to translate an exponential relationship into a linear one. This is an advanced transformation that will generally only be applied if you have a good statistical or mathematical basis for using it. Sometimes you will want to multiply by or add a certain value to all your observations. This can also be accomplished with Power Query's numerical transformations. As a final note, you can save memory and make your columns more readable by rounding your data in Power Query to reduce the amount of decimal places. This is especially recommended if you have many rows in your dataset. Date and time columns are special types of numerical columns, as the standard numerical transformations cannot be applied on them. However, there are a series of transformations dedicated especially to them and will come in handy when you are preparing a date dimension to analyze your dataset. You can extract specific properties of a date column like the year and month, as well as derive properties such as the start or end of a particular year. This can be very useful for your analysis if you need to calculate averages based on how many days have elapsed in the year. You can even extract the age from a date column, which is typically applied when you have the birth date of employees listed on your dataset and you need to figure out how old they are. We encourage you to experiment with the options available to you in Power Query when it comes to date columns, as they are quite extensive and varied. Let's try this out ourselves by working on some sales data for AdventureWorks.
Okay, that's interesting. Time to get our hands dirty. So numerical versus date transformations. You have to know that dates are different from numbers when working with data sets in Power BI as a data analyst in general. It's a certain transformations can be applied to both numerical and date columns, while others are unique to each column type. So you will need to identify which transformations can only be applied to numerical or date columns, while which transformations are applied to both. The following is a list with a series of transformations. Drag each transformation to the column type for which that transformation is applicable to. If it is applicable to both, drag it to the column that is labeled both. So the numerical columns, this column, both. Calculate age, definitely a date column. Extract weekday, date column. Square roots. I'll go for you can square a date. Multiply. I'm thinking you should be able to do this for both. Few missing values. This should be for both. Multiply. Can you multiply a date? 33 times 4. Okay, let's see. So I was thinking it's not possible to even multiply a date. Never did that in primary school mathematics. So let's continue from there. So the next lesson is on numerical transformations. Okay.
Now let's explore some of the numerical transformations in Power Query. We will be working with stock price data of the S&P 500 index. The S&P 500 is a collection of the 500 largest public companies in the United States. All the columns in this dataset are considered numerical columns, including the date column on the far left. This dataset contains the adjusted closing price for every day from the 22nd of February 2021 to the 18th of February 2022. We can verify this with the column profile feature. You can see the minimum and maximum correspond to the dates I mentioned previously. There are only 253 rows in our data, but this is to be expected since the stock market only trades on weekdays and non-holidays. The volume column contains the daily traded volume in units of stock. However, it can be a little hard to read. We can make it easier by dividing the column by 1 million and then rename the column to specify that the units are millions of units of stock. We accomplish this by going to the standard transformations in the transform ribbon and click on divide. The column is much more readable now thanks to this transformation. The next column we can transform is the deviation to mean column. This column contains the difference between each day's closing price and the average closing price for the whole year. We can use it to calculate the variance of the S&P 500, first by squaring the column and then dividing by the number of samples minus 1. To square the column, we go to the scientific transformations, then we select power, then square. In order to divide by the number of samples minus 1, we select the divide transformation and input 252. Now we're almost at the sample variance. All that is left is to sum the column, which we can do by using the sum transformation under the statistics icon. The transformations under the statistics icon will summarize your entire dataset into just one number, which you won't be able to build measures with if you load into Power BI. We use them mainly for intermediate analysis in Power Query to understand our dataset more. If we take the square root of this number, we'll get the standard deviation of the S&P 500 for the last year, which is a good measure for the average volatility of the US stock market. We can also confirm that this result is equivalent to the statistic in the column profile feature. Let's remove the last two steps here, calculated sum and calculated square root, so we can work with the whole dataset again. When it comes to date columns, there are special transformations that can be applied. Let's say we want to see which days of the week are trading days in the US stock market. We can use the name of day transformation located under the date icon in the transform ribbon. Note that this transformation will replace your column with text data, so it is generally best practice to duplicate your date column first, then apply the transformation on the duplicated column to preserve the original dates. We can also do the same for the month names. This shows us that the month with the most trading days is March, while both Wednesdays and Tuesdays are tied for most trading days. There are a variety of other data transformations you can apply to derive some more insights from your time series data. You will now apply these to clean and transform AdventureWorks sales data.
That's interesting. I've never worked with a stock data before, but going through that lesson, probably I'll have to watch it again in my leisure time just to practice those techniques he was using there. So let's go on to reading the instruction and practicing with what. So we have 4 tags here. 1, 2, 3, 4. Let's say 3 tags to complete. So absolute value and rounding. So you are tasked with analyzing arguably the most important part of the AdventureWorks cycle data set, sales data. So we want to work with the sales data now. Your manager has been impressed with your work so far, so he's sure he will be able to clean this data up as well. It tells you that there are a few columns that need adjustments before going into the reports, as there seems to be negative values in them. It also lets you know that the company convention is to round all sales-related figure to 1 decimal place, so it wants you to make sure that you do that. Sorry about that. So open the Power Query editor and load sales data. So we're going to open a fresh Power Query file. Let me just open my Power BI desktop very quick. So I'm going to load the sales data. Do not forget, all data sets is linked under this description. Do make sure to download them so you can practice and get your hands dirty also. So I'm looking at the sales data actually. We have the sales data of 1997 and 1998. Oh, from 1996 rather, 1997, but we have a file called sales data. So click the link under the description to download these files. So I'm also open a new report, a blank report rather. I just go to, they are loaded as Excel workbook. Okay, let me look for the file parts. So my data sets is loaded here. So I'm looking for this sales data. So we're actually using this sales data according to the instruction. So it now says from the dataset folder, enable the column profile feature and make sure you are profiling based on the entire dataset, not just the top 1000 rows. So let's go back to Power BI. While the sheet is still loading, let me just click on sales. So this is the old dataset. Where does the sheet one? Sales total. Okay, I think we have the they're definitely the same data sets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So definitely going for that sales column there. This sales sheet here rather. So it should be the first one here. Let's open it and for it to launch the Power Query editor. Aha, can see. So the instruction says if you look down here, just below the mouse part, you can see column profiling based on the top 1000 rows. So the instruction says you should enable the column profile feature and make sure you are profiling based on the entire data set, not just the top 1000 rows. So to edit that, you're just going to click this and say column profile based on the entire data set here. You need to analyze the numbers based on the entire data set, not just the first 1000 rows. So let's go to the view tab and click on column profile. So we're going to see the column profile of each column. Definitely the data set is quite large, that's why it is taking time to load. So let's move on to the instruction. So check the distribution of the order quantity and extended amount columns. Do you notice anything strange? So you go to the order quantity and extended amount column. Let's go to order quantity. Let's look at this order quantity right here. This is the extended amount column. So these are the two columns we want to work with. Order quantity and the extended amount column. So let's look at the column profile of that. Aha. So merely looking at it, we have a count of these over 12,000, 121,000 rows of data sets we have here. We have 0 error, 0 empty, 47 distinct, unique 8. We have minimum value is -16. The maximum value is 44. The average is 2.23. The standard deviation is 2.5. There are even numbers of over 28,000 and odd numbers of over 92,000. So the question said, did we notice anything strange? You can see we have negative numbers. Merely looking at the value distribution right here. We have both negative numbers and 1 is the most occurring number here. It occurs 60% of the time. Let's look at the extended amounts for, let's see what you can observe there. Aha. So the minimum values are both negative. We could also say that we have negative numbers in the data sets. So it's not possible that a unit price for a product is negative dollar. You can't go to a store and see -$10. That will probably they should just put free on the package. So that's what I've noticed so far. Okay, apply the absolute value transformation on the other quantity and extended columns. Let's apply the absolute value transformation. Okay, maybe that will get rid of the negative values there. So I think that is correct. Let's see other quantity. So if I go to transform absolute value, where is that? Oh, this is the absolute value feature. It's other scientific. If I click on that, let's see what's going to happen. Let me do it again. Okay, let me just click on column profiling again. I think the absolute value helps us to get rid of the negative values in a column. Probably due to my error, someone just mistype minus $10, which is not, you can see. I think, oh, nice. So it has gotten rid of the negative value. So I'll just do the same to the extended amount here also. We notice that we have negative values in this column earlier. As we have negative minus 201,995. So to do that, let's go to the transform tab. I just click on absolute value. So it gets rid of that. That's quite interesting to know. Ooh, I can see negative value here. Okay, let me just do it one more time. Oh, transform. I think it has not affected. I did click it very, very earlier before. Glad I checked it again just to double confirm. Let's not check it now. I can see. So the negative values are gone. So I think that's what absolute value does. It helps you get rid of negative numbers when it is due to human error. So round the unit price and extended columns to one decimal place. So also round them up to one decimal place. Which column did I do the calculated amount? Oh, I think I did a mistake earlier there. I was working with unit price. Let me check order quantity. It said apply the absolute value transformation on the order quantity and extended amount. Did I do that on the order quantity? Yes. Okay, I did that on the order quantity. I will go back here also. Yeah, I think I did that on the order quantity. So it now says the next instruction says round the unit price and extended amount to one decimal place. So round the unit price, let's look at the unit price here. Unit price, extended amount. So let's go to transform and statistics. Standard. Where is it? Round. Okay, this is the rounding. Found it. Say round. If I say round up, I don't want to round up. Let me just round. So I think it's going to ask for decimal places. So then I'll type 1. Aha. You can see one decimal place 5.7, 28.8. So let's do the same thing for this column also. Round one decimal place. Aha. So we are doing code transformation right there. So what is the minimum of the extended amount column? The minimum of the extended amount column. Let's go back to column profile. I think the minimum should be for something if I paid attention earlier. The minimum should be 1.4. Oh, yep, 1.4. Let's log that in. 1.4. And we need it. Well done. You use rounding and the absolute value transformation to clean up some important columns in your data sets. So moving on to the next, multiplication, addition, and square roots. You have performed multiplication, addition, and square roots. So after removing negative values, the next step is to fix the discount and unit price discount PCT columns. That should be percentage. The company usually states their discount as a negative value so that the impact is clear and it is easy to distinguish from the other columns. In addition, something seems to have gone wrong with the discount percentage column. I guess so. Itself as the values are too small. Okay, so let's continue from there. So make the discount amount have negative values instead of positive. So how do we make it to have negative value instead of positive? Let's see that discount amount. So this is discount amount. They are all positive. Let's look at the column profile real quick. We can't say negative values there. Take your time to load. We have quite a large data set in this sales table. And it is the sales record of over 2 years, I guess. So how do that then make it to have negative values? Let's go to the transform tab. Hmm. So look for how to add a negative value to the numbers. Cited is a sign here. No, that's quite funny. Uh, if I multiply, so what are you multiplying by? Is it by 1? Okay, you can do this by using the multiply transformation. You can find the multiply option by clicking the standard icon in the transformation ribbon. So let's use the multiply feature then. Okay, we are asked to make them all negative. Okay, that's interesting. Make them negative. I've just had -1. Let's see, definitely -1. Where is multiplier? Let's multiply by -1. Aha. Now they have negative values. Quite simple to do. Now, multiply unit price column by 100 to correct its value, then format it as a percentage. I'm going to multiply this by 100, the unit price discount. Where is that? This is it. You can see we are going to multiply them by 100. So same thing, standard multiply by 100. Aha. Then we're going to change this to percentage rather than decimals. So we're going to the format tab here. That should be format tab. Oh, format tab has to do with numbers. Let's see. Percentage here. Percentage should be by 100. Let's do 100 percentage. That's calculate percentage, but probably we won't know the percentage or else it comes out. I guess it's not going to show that it's actually in percentage, just normal decimal like this. When I multiply by 100, that's what it's showing. Let's go back here. Almost same result. Calculated percentage. Okay, let's move on. A special tax is being retroactively applied to all sales to fund a special government program. Reflect this by subtracting 1 from each row of the sales total. We're going to subtract 1 from each row of the sales total. The sales total minus 1. Transform. Go to the statistics. subtract 1. We are subtracting. I don't need to say minus 1 again. That will make it positive. So by subtracting 1 from each row of the sales total. So let's pay attention to this. This is 19223. Let's see. It will be 1922. You can see the value was 19. When we look at it here, it was 1923.74. After subtracting 1, it will be 1922. So that means the calculation is absolutely correct. So if you move on to a mistake in the calculation of the total product cost cause the figures to be squared, take the square root of this to fix it. A mistake in the calculation of the total product cost cause the figures to be squared. Take the square root of the to fix it. Total product cost. Where is total product cost? This is it here. I think we were working with the discount earlier before and unit price that we did our percentage on. So it's a mistake in the total product cost makes it to be squared. Take the square root to fix it. We're going to use square root to fix this. Very scientific square root. Then it has fixed the total product cost. Okay. The next instruction says round the sales total and subtotal columns to one decimal place. So I can actually round both of them, the sales total and subtotal. So we have to round them to one decimal place. So if I go to scientific, no, rounding rather, round to one decimal place each. Aha. So I could do that at a time just like that. So what is the highest discount percentage that the company has recorded on a sale? What is the highest discount percentage? So we want to see the highest discount percentage. So if you go to the discount column, highest discount percentage, we actually use this unit price discount calculation and look at the column profile. If you look at the highest and the minimum, we should be able to get that. Or if I can also filter, okay, let's see. The maximum is 0. You can see the maximum is 0.13 percentage, while the minimum is 0. So let's log that in. This is it here. Ooh, I feel that. Oh, it's not possible 0. It should be 13%. Aha, so I missed that. So I'm seeing 0.13, 0.13, that is 30%. So don't get confused with it. So let's continue. I took a hint the other time, so I missed my mark of 100%. That's quite funny. And this is the last part, date transformation. So we've worked with number, absolute value, and rounding. We did multiplication, addition, and square roots. I want to do some date transformation real quick here. It says your manager is interested in analyzing the seasonality of orders as well as the shipping dates. According to company policy, most orders should ship out on Monday. However, the shipment provider tends to delay orders to the next day when more workers are available, or try to ship them out a day earlier so they can charge a higher rate for weekend shipping. He wants you to help assess the impact of this. In addition, he would like to know which week of the month orders most likely to be received, so he can plan to keep warehouse staff available during that week of each month. Okay, let's do this. Duplicate the order dates column. So if you go to the order dates column, order dates, this is the order dates. So I could just right click on it and duplicate column, and it's going to bring it to the end of my table here. Extract the week of month number from the order dates column. Extract the week of the month. So I want to know the week of the month this day falls in. We're going to transform dates, week, the week of months, the week of that month. When you look at week of months, okay, so it's the second week of the month. You can see, so it's going to be, okay, this is a month, the first week in a month. We usually have 4 weeks in a month, minimum 4 weeks in a month. So that's what this calculation is doing for us. Week of months. So let's see that. So we have that. So we rename the other column to week of months. So we're going to rename this column to week of months. So we've just rename that to week of months. Transform the ship date column to have the name of each day the order shipped out. Ship date column to have the name of which day. Okay, ship dates. So we go to the ship dates column, right, the day the order was shipped. And let's duplicate this also. Duplicate column. Yeah. But we have to transform that ship date column. I can just transform it, just create a new. So okay, let's change this on to day of week. I don't want it to have day of week. Let's have it to have name of week. It should be name of week. Name of day rather. It should be name of day. So we're going to start out the day the order was shipped. Ship out on. So we name the ship date column as ship day. So we should name this as ship day. Ship dates. So these are the days our orders were shipped, even though the date was recorded. And it's going to ask what days were orders most likely to ship out. So we could just use the column profile feature to answer that. So you can see which day are the highest shipped orders. So that should be Tuesday, then followed by Saturday, then Friday. Sunday has the least ship day. That is Tuesday. Aha, we knew that. It seems your manager instincts were correct, that the shippers tend to delay the orders by a day. So that's quite interesting. And we just answered all that and did some transformations right there. Interesting transformations to the sales column.
Congratulations on finishing this course. You started the course with an introduction to Power Query. You'll learn about the importance of clean data, the different data types in Power Query, and some basic structural transformations such as removing or sorting columns. Chapter 2 focused on the data preview features in Power Query, column distribution, column quality, and column profile. You practiced the use of data preview features to help identify and fix common errors. Chapters 3 and 4 were about data manipulation on text and numerical data. You became acquainted with the concepts of clean text and numerical data, splitting and combining text columns, and various numerical transformations to produce higher quality analysis. I hear you thinking, now what? Have no fear, more Power BI content is here. Data transformation in Power BI is the follow-up course where you'll learn about pivoting tables, joining columns, the advanced editor, and the core of Power Query, AM language. I'm looking forward to seeing you soon in the next course. I hope you've enjoyed this one. Congratulations again.
Yeah, we've totally enjoyed it. If you agree with me, let me know in the comment section. If you truly enjoyed this data transformation part of becoming a data analyst. So we'll come back to this. Got it. Yep. We're moving on to the next course, which is, I think the next course is same data preparation in Power BI, but advanced data preparation. Let me see. So data transformation in Power BI. I think it's the advanced part. This is the advanced part. Data transformation in Power BI. Part 2, combining data in Power Query, custom columns, and advanced editor, which is the M language editor. So I look forward to this on day 22. That should be our next course. So if we go to the track section here, career track. Really quick there. Come on, it's still loading. Aha. So we're like 28% through the whole data analyst Power BI career track. So I click on this. So we've covered 5 courses now, if I'm not mistaken. Yeah. We are moving to the 6th course out of the 17 courses. I think 17 or 14 courses in the whole career track. That's quite a huge tons of lesson to complete. Aha. I'm correct, 17 courses. So we are moving to the next one, data transformation in Power BI. So we've covered data preparation, and then we're moving to data transformation in Power BI, data modeling. So I'll see you tomorrow, day 22, on this data transformation as we begin this data transformation in Power BI course. Alright, so thanks for staying to the end of the live stream. If you found value in this video, do well to support the channel by hitting that subscribe button, put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. Also, watch out for my other series or my other videos on the channel where I tend to share my knowledge and how to become a data analyst and my journey to become a full stack data analytic person. Currently, I'm a top rated plus freelancer on the Upwork platform. So if you're looking to start your freelancing journey and looking to upskill yourself as a freelancer and earn more money, I've linked the course under the YouTube description, which is the Freelance Client Magnet course by my coach Bengali. He's the one that taught me all about freelancing and helped me to scale my freelancing career up to this stage that I am today. So check out the course under the YouTube link description and enjoy a 10% discount. Don't forget to go watch the next video on the channel. And I'll see you tomorrow, day 22. Be on the lookout. Definitely coming back here tomorrow to continue learning. Do have a wonderful day. Bye for now. Make sure to practice and enjoy the rest of your day.